So I'm Mark Imbriaco, and I'm super excited to be here. I've been at Monitorama a bunch. So I'm the founder and CEO of a company called Operable, and that's all I'm going to say about that until tomorrow, since I'll use your time then. But the way I self-identify is as an ops guy. The whole company thing, whatever, I'm an ops guy. I've been doing ops for 20 years, and I've done lots of technical operations and software development work over that period of time. And I've had incredibly good fortune to work at a bunch of interesting companies, but even more good fortune to work with some amazing people. And I'm going to talk a little bit about that. So the title is Humanscale Systems, and that'll be a little more self-evident as we go. I love Monitorama. I was at the first Monitorama. I was lucky enough for Jason to ask me to speak, and it's just gotten better every year. And it's interesting. For those of you who were sort of in the industry back in 2011, 2012, 2013, think about how we looked at monitoring. This was the meme, right? I don't know how many of you remember that, but this is the way we talked about monitoring. And it was grim. We used this hashtag all the time. It spawned birds of a feather sessions at conferences. We used it to talk shit about all the software that exists. Now, don't get me wrong, it's people's prerogative to talk shit about bad software. But it got a little out of hand, and it wasn't helping. And I remember distinctly one of these birds of a feather sessions at Surge in 2012, where one of our thought leaders in residence summed up the session for us. This was pretty much the theme of the session. So we started out the birds of a feather, and the person who was running it asked everybody to go around the room, introduce themselves, and say one thing they hated about monitoring, which really sets the tone in a great positive way. But what the follow-up to this was also great, and I stole this image from a blog that recapped that session from somebody else who was there. And this was another quote that I got from that same blog. And I'll just read this one verbatim. It says, "I propose that monitoring sucks, but it's improving. The tools we have today are better than we had a year ago. Composability is vital to providing tools that are flexible enough for a wide variety of businesses." And it struck me that this was very different than the sort of view that the rest of us in that session, myself included, had. We were all very doom and gloom, but there was one person who was positive about it. And you can guess who that was. It was our good friend Jason. And Jason not only went to this session and recapped it in a positive way, he went out of his way to think about what he could do to reframe this monitoring sucks meme. And what can we do to improve the situation? Instead of talking shit about it, what can we do? How can we make things better? And we went from monitoring sucks to monitoring love, and 600 of us in Girding Theater every year. And that's kind of amazing. And really, the thing that strikes me about this isn't so much that Jason's awesome, which we all know. It's that the vision that he had for Monitorama was that if you got a bunch of smart people who were passionate about this subject together and put them in the right environment to be productive and have productive conversations, you could move the industry forward. We could change the shape of the community. And he was right. He was obviously right. And we can see that he was right. And I think that we can apply that same sort of focus on improving situations and thinking more about the human elements of our communities to larger parts of our organizations. So that's the topic of my talk. So it's about the people, and it's always about the people, and the recognition that people are critical parts of our systems. So we talk about our systems a lot, and we often think about our systems in terms of the technical parts of our systems, right? We don't focus a lot on the people, but I think the focus on people is what a lot of us found appealing about the idea of DevOps. When this idea of DevOps, or the word, not really the idea, the word, a lot of us have been behaving that way for a very long time. But when this term came around, a lot of us were excited about it initially because it said a lot of good things about putting focus on the interactions between people and improving communication and focus on outcomes and how we can work together to achieve better outcomes. And all those things are awesome. But we didn't really get any further. And DevOps has sort of led us astray to an extent, because we talked a lot about culture with DevOps, and I think that's important, but we talked about it in an unhealthy way. We started saying things like, the tools don't matter, and I'm guilty of this. And it's stupid. It doesn't make any sense. Of course the tools matter. And it's not just because I'm a tool vendor now. The tools obviously matter. The tools matter because the tools influence the way that you interact with the rest of your system. The tools control the tools have an impact on the way that you interact with your system. They move the behavior, to use Greg's term earlier. They have a tremendous impact on the behavior of your system, specifically on the interaction between the human component and the technical component that the tool is related to. And the technology matters beyond the tools because, let's face it, the vast majority of us got into this industry because we like technology. So of course the technology matters. If the technology didn't matter, we'd be doing something else that's a hell of a lot less stressful. Like, I don't know, pig farming. So the technology matters because we care about the technology. That's why it matters. So we talk about a lot of this technology stuff. We care about it a lot. We spend tons of time thinking about technical details around all of these things, around databases and file systems. We can give you nuanced answers about why we made all of these decisions in our technical systems when we built them, and about how those decisions have been working out, and about which ones of these software components are more horrible than others. They're all bad, but we can at least give you some context about which ones are worse. And we have strong opinions about everything. From configuration management to monitoring tools to ZFS versus Linux. You want to talk about infrastructure patterns, we'll talk your ear off about AWS and Google Cloud and Docker and deployment pipelines and everything else. And we'll wax poetic about our choice of editor and tell you when you're making bad decisions. And we sweat the details about our technology choices. We sweat them not just because we're a little OCD. We are a little OCD, but that's secondary. But because they matter. The details of our systems, of our technical systems, matter. The way that our components are constructed and the way they interact with one another matters. All of these things, they're not just details of the system, they're fundamental to the way the system as a whole behaves. And it's impossible to have a meaningful view of our systems without understanding the details. So we obsess about the details. And we love the technology. And we build tools. We do what humans have done for thousands of years, millions of years. We build tools. We build fancy tools like the CNC router I built at home so that I can cut funny shapes in wood. We build tools to gather telemetry data from our systems. We build tools to understand how they're behaving and how they're performing. And we build tools to manage our applications by turning on or off features. We build tools to deploy our systems and to deploy the tools that deploy our systems and to deploy the tools that deploy the tools that, you get it. We build tools for everything all the time. And the fact that some of these tools are just shell scripts is beside the point. And we also know that software is horrible. This is a slide from my 2013 talk at Monitorama, and I had to use it again because I love it. We recognize that the technical systems that we work on are fragile. At the best of times, they're fragile, and the components are failure prone. All of the components, the software components, the human components, the hardware components, they're all fragile, they all break all of the time. Hardware fails, data centers lose power, software defects crop up literally all the time. And any number of things could go wrong, and we tend to focus, as an industry, a ton of energy on understanding or trying to articulate what those behaviors and what those failures might be and put guardrails up against them. And that's great, because it lets us deal with a lot of things that could be significant problems without them becoming significant problems. So we build ever fancier tools, and we build automatic remediation, and we don't have to wake up at 3 o'clock in the morning to empty the log directory anymore because we added a Nagios event handler, or we don't have to restart that service because we wrote a script to do that for us. And suddenly we think that these systems are a lot less fragile than they really are. We start to think that automation is more valuable than humans, or more reliable than humans. Because the humans are, of course, fallible creatures, right? And especially when we wake up at 3 a.m., we're really fallible. And of course, everything breaks at 3 a.m. And then we have these ideas like no-ops, and this is how I write no-ops. n times oops. We try to reduce everything to an API call or to a script, and we start to question whether operations is a thing. We can discuss whether or not it's an organization or not, but it's I think, inarguable that somebody has to do the work. And we build all these automatic remediation tools, and we set up auto-scaling groups to replace those instances, and we think that no-ops is actually a thing. And it's just not. Because the reality is, we have a complex socio-technical system. We don't just have a technical system. The humans are an inextractable piece of our systems. We can get as creative as we like with automatic remediation, and it's great. I think those tools are incredibly valuable. I don't want to wake up at 3 a.m. to rotate a log file ever again. That's stupid. It makes no sense. And we should reduce those things to being behaviors of our systems rather than incidents. So if we have tools that turn rotating that log file into a behavior and dealing with the fact that that doesn't always work as another behavior, then we're going in the right direction. But the problem comes along when we start to think that we can anticipate all the failure modes of our systems. And it's just not possible. We can lull ourselves into this belief that we don't have single points of failure, or that we've anticipated all the edge cases, and then science intrudes. And we have people like Dr. Richard Cook, who wrote a famous paper called How Complex Systems Fail. It's one of my favorites. This is item number 12. It's my favorite because it's self-serving and it says what I like. But it says human practitioners are the adaptable element of systems. And I'm going to paraphrase the rest of it. But the summary is that we've got these technical systems that are inflexible. They do what they were designed to do, what they were told to do. They solve the kinds of failure modes that we were able to imagine or anticipate up front. And the word that I have for those sorts of failure modes is boring. Those are the boring failures. Those are the ones that we can anticipate. They're not interesting. We should be able to automate those away. We shouldn't wake up for those. But what about the ones that we can't anticipate? The ones that are unknowable? Because the reality is the number of interactions that exist in our systems make it not just prohibitive, but functionally impossible to understand all of the failure modes. And if we believe that we can somehow eliminate ops and we can hand everything over to the machines, then we stop designing tools that are built for the way that our humans interact with the systems. And when we do have these failure modes that happen in ways that are not only unexpected but unknowable, we significantly harm our ability to respond. So get to the point already, Mark. Where are we going? You said a lot of words, but you didn't really say anything useful yet. So DevOps, I tweeted this last week or the week before, and I got a ton of, it was total Twitter bait, but it worked. So the practice of spending countless hours appeasing our automation tools because of a fear of shell scripts, SSH, and for loops. I said this when I was particularly irritated from appeasing one of these tools for several hours. But it's kind of true, right? We spend a ton of time building tools and scripts and workflows and solutions to problems that these tools are great. These, don't get me wrong, tools like the Chefs and Puppets and Ansibles and Terraforms and CloudFormations and Cloud Foundries and all of these kinds of tools are great, and they're very useful tools. But we spend a tremendous amount of time writing tools to appease our systems, to meet the needs of our technical systems. And we don't spend nearly the same kind of time thinking about the way that our human components of our systems interact. So think about that for a minute. Think about how we think about the ways that the components within our technical systems interact. Adrian can talk to us a lot about microservices. And imagine a world where you're building services in your technical system, and you haven't taken the time to design the API between those services. You wouldn't have a particularly good outcome there, I don't think. But we do that all the time with the human sides of our systems. They're an afterthought that is given no consideration until the shit hits the fan, and we're grepping through log files that don't have the data we need, or we're whipping out strace, or if we're lucky enough to be on a system that has dtrace, we're trying to shoehorn tools in to solve problems that a little bit of thought about the API about the human interface, rather not the API, the human interface, the human interactions with our system would have solved for us. If we'd have just given ourselves one more tool, we'd have spent 10 more minutes, we'd have thought about what are the things that we might want to do if the system is down, what are the things we'll want to know. If we just gave a little bit of thought, if we gave a fraction of the thought that we gave to our API designs, to our human interactions, we'd be in a much better place. So I've got a few ideas about some of the things that we might start to think about, and I've only got 5 or 6 more slides, and if there's time, I'd love to take questions. But these are just to get you guys thinking a little bit about, and sorry, I said guys, I really should have said folks or something. It's a habit that I don't mean guys, but I'm old. I apologize. So these are just some ideas to get you thinking about the sorts of things that I think might be interesting. So first, think about the intent. You know, if someone is, there's a term for this interesting that I've heard at times, pre-mortems, right? So think about what a failure mode for your system might look like and how you'd recover from it. Obviously, if you can build tools around solving for that failure mode, great. Think about the interactions between your systems, and if they're not able to talk to each other, how might you want to look at the state of the system? Or how might you want to interrogate a particular component of your system? Or, you know, what are the kinds of outputs you would want to see? Or if you know that a disk volume is bad, what might you want to look at? You know, do you want to see just the bad disk, or do you want to see some arcane output? Right. So think about the intent. Think about the problem that you're likely to want to be solving. Don't cut off other avenues, but think about the likely use cases and put them front and center. And make them easy. Make the obvious things easy while leaving the less obvious things possible. And consistency is really important. Consistent interfaces across your tools, across your interactions, let you build muscle memory and intuition, which is one of the reasons why humans are so adaptable, because we're really good at spotting patterns, and we're really good at developing muscle memory, and we're really good at taking intuitive leaps. So building tools that allow us to use them without having to give them a whole lot of thought, because they all work the same. They all have a similar pattern. They use similar command options. You know, if we have an ID for a particular type of resource, we should be consistent about how it's applied. These sorts of things are fairly obvious, but again, a little bit of thought into how we design our tools can pay huge dividends. Think about how you might use this tool with other tools. Will it blend, right? So if I've got 2 systems that talk to each other a lot, and I know that if I'm looking at one system, I'm very likely to be using another system, think about how I can shape the outputs and craft the output of one tool to work with the other one as input. Think about how I can build pipelines between them. You know, Unix is all about building small, sharp tools and composability and adaptability. Let's embrace that in the tools that we build as well, instead of writing do-it5.shell. Think about what our practitioners, as Dr. Cook said, need to get their jobs done. And consider the state of mind of the people that are working with your tools. You know, when you get paged at 3 a.m. and you know that the kind of problem you're dealing with is one that's potentially scary, think about what sorts of things you can do to make the person who's responding more comfortable, right? So maybe you have a particularly risky remediation to perform that you know someone's going to be uncomfortable with. Maybe you can add a dry run mode. Maybe you can give them some more knowledge about what your tool is going to do before it actually performs the action. What are the things you can do given the state of mind that you expect the person using your tool to have at the time? And I've only got one more. Anybody recognize this? It's really small, but I bet somebody in the room knows what it is. Anybody? Yes! So the last thing I have is not even once. Yeah. So don't build tools with interfaces like that, or I'll find you. Thanks, that's all I've got. I don't know if I have any time left. Do you have time left? Anybody? Yeah.
Aside from your own thing, are there examples of command line tools in particular that you think have done things really, really well?
Yeah, I think one that comes to mind immediately is kubectl, the Kubernetes command line client. Is awesome. It lets you output JSON for all of its actions. It has a very consistent interface across all the different types of resources you would want to manage. I like it a lot. I think they did a tremendous job there. That's a great example. The Google Cloud tool, it's the same basic framework. I think they did a great job. So tools like that, tools that, they have a very consistent interface across all of the available options. They let you output the data. And one of the things I didn't mention that I meant to, one of the things I like about the kubectl command that it does is it's got a default view of the resource that it renders when you run it. Or you can say, give me the JSON and give me all of the attributes. They're there, they're just hidden most of the time because you don't need them. But if you want them, you don't have to go out of your way to query some API somewhere. You just run the command again with a different flag. Anybody else? Awesome. Thanks.